Thank you to, to the organizers of this meeting for giving me the opportunity of being here today. This is the first time I come to a EuFMD meeting, and it really gave me a different perspective about the importance of the work I do. Usually I am by training a molecular virologist, and I enjoy Keystone meetings, Gordon Conference, Europic meetings, and because I'm fascinated by the basic research, but I never think of the importance that my work can have towards a universal goal. And well, I really care about humanity, and preparing this talk, I realized of this tangible perspective in helping humanity, just contributing with a little grain of salt. So in preparing the talk, I came to look in the FAO news and some facts that I also found that were really interesting and gave me this perspective I just mentioned. That, for example, producing producing livestock employs at least 1.3 billion people in the world, which is almost like 15–20% of the world population. You know, sometimes for me, numbers don't mean anything unless they are relative to something else. So in addition to that, I read that 600 million people of the world keep livestock as an essential source of income, that livestock production accounts for 40% of the agricultural output in developed countries and 20% in developing countries, that still, you know, 2018, we use animals as an important source of power in this world, and that also, in addition to improve the health of our animals, so our work can help in developing better livestock and eventually assist with the control of gas emissions. That is actually something, a particular topic I care about in order to preserve our world. Okay, this is a slide that you also, in relation with what I just mentioned, this is a slide that you know better than me, but also I reread it, and I pay more attention to those numbers. And something that caught my attention, for example, with relative numbers, was that the cost of an outbreak in a small country like the 1997 outbreak in Taiwan represented a cost of $6 billion, which is 1.2% of their GDP. That, for me, is huge. When I read 20 billion, 300 million, you know, those numbers don't mean anything if you don't know really how much is that amount of money relative to what a country can produce. So, you know, I was astonished. Again, this is a map that you all have, several people have presented in this meeting so far. And obviously, it shows that most of the inhabited world is endemic for FMD. And the map is deceiving when we look at it in the flat screen, but I took 10 minutes to look in the internet, and, you know, with my poor computer skills, because I am an old woman, you know, I calculated to say that it's endemic in 50% of the world, what does it mean? Well, FMDV is endemic in 50% of the world, but in that 50% lives 76% of the world population. So that gave even more importance to this feeling I was mentioning before, you know, of if I ever can contribute with anything to humanity, I will. After knowing this, I, you know, feel much better. And it made my scientific career, basically. So again, you know better than me what are the methods to control FMD, and I agree with Tim Dole. I just met him, saw him first time in this meeting, that the inactivated vaccine is excellent. So I do think it's excellent, and I do think the quality of that vaccine have improved in recent years, or in recent decades, let's say, and it's very good. And we have to admit that it actually allow for the eradication of FMD in very important regions of the world, the world that drives development of the part of the world that drives development of the whole world, because the whole world relies on development of the developed world and sustainability of them. So I'm not going to talk about these details, because we all know what are the requirements of an ideal vaccine and what are some of the limitations that the current inactivated excellent vaccine has. But perhaps in this slide, I oversaw it a little bit, but let's say I wasn't so positive or in checking the limitations of the current vaccine, but I just think that if by using for over 70 years this inactivated vaccine, we haven't been able to achieve disease eradication, there should be a lot of alternative or a wider way of thinking that we need alternative vaccine platforms, in addition to maybe alternative policy measurements, and also development of veterinary service and other things that could be really important to succeed in better controlling this disease. So you also know that for the last 20 years, more or less, there had been a strong effort in Plum Island that was originally started by Marvin Grabman, which was my mentor, and I can say one of my best friends. He retired like in 2012, at the end of 2012, but I talk to him quite often, actually. And he actually was instrumental. He brought to Plum Island the technology of constructing an alternative vaccine platform that involved the use of replication defective human adenovirus type 5. And actually, he was lucky. He was lucky. He had a postdoc in his lab who had come from a lab that worked with human adenoviruses. So he was actually very handy in making these constructs. So originally, this vaccine was made in those days, we didn't have all of the genetic tools we have today, but we did have the infectious clone of FMD. So basically what he did by restriction digestion was to delete a part of the genome and leave the capsid, the coding regions for the capsid behind. And it actually, because I always remember it was a ZO1 site, restriction nucleoside, he made a deletion and it left behind a portion of the 2B and the 3B genes, and of course the 3C protease for processing the capsid. So this construct was cloned into the human adenovirus, and they also cloned a construct that have a mutation in the 3C, and they proved that they could generate viruses expressing these empty capsids, and something that didn't happen if the 3C was mutated. This platform contained basically, like any VLP, all of the protective capsid epitopes, and it lacks most of the non-structural genes. It actually allow for a clear differentiation of the infected from vaccinated animals. And this is something that it was also, the vaccine fulfilled this by serendipity, I would say, because I had just joined to his lab and we were talking, it's strange, the 3ABC ELISA, and we haven't even looked at the antigen that the kid had, contains 3ABC, and our vaccine has 3B and 3C. And how come we can, you know, in our preliminary experiments, we could distinguish. And then we realized that the epitope that is in the kid is actually the one that is missing in this construct that by serendipity we deleted for cloning purposes. And so just by luck, let's say, originally the vaccine was DIVA. And the vaccine, in addition, like our colleagues said before, could be produced in a BSL-2 laboratory. And eventually, we partnered with Merial, and the vaccine was moved to the next stage of development. So in the original work, this vaccine, which was constructed for the A24 serotype and subtype, was demonstrated to be efficacious with just one dose administered intramuscular at one site with a dose of 5 × 10⁹ PFU of the adenovirus, and with challenge at 7 days post-vaccination. And when I say it was efficacious, it protected 100% of the animals that were vaccinated. So the same, we got a similar pattern in cattle, in fact, inoculating also with the same dose by the same route and challenging at 7 days. So this is just the first data done with few animals where the vaccine was compared, the adeno vaccine was compared in parallel in the same experiment with commercial vaccine formulations with inactivated antigen and adjuvant. And we, of course, we know challenges were done at 14, 42, or 7 days. And we noticed that although the levels of neutralizing antibodies were much lower when we tested at 7 days post-vaccination, all of the animals were protected. Mm-hmm. Similarly, the results were obtained in cattle using the same dose. So, but then in reading data from the literature, and also in trying to address the cost that this vaccine could have, because it's an adenovirus, and we all know veterinary vaccines have to be really cheap. And we really made a lot of efforts in trying to improve the potency of this vaccine. And in reading basic research, we learned, actually from work published from colleagues in PeerWright and others in different picornaviruses, that the inclusion of that the 2B and the 2C proteins of foot and mouth play a pivotal role in developing membranes in the infected cells with foot and mouth that could serve as a matrix for foot and mouth replication. So we then, hypothesized that perhaps if we included those proteins in our vaccine, we could actually improve the potency, the stability of those capsids while they were producing the live animal. So effectively, the data demonstrated us right, because inclusion of the 2B in the A24 adeno original platform actually allow for improvement in potency. And we also made constructs, a construct that had been challenging for us, which was the adenovirus FMDV 401 campus, in which we could never get full protection. Inclusion of the 2B in that cassette also improved efficacy. So this was the data in pigs. And in this particular experiment that we use our standard dose of 5 × 10⁹ PFU of the adenovirus, we noticed that whereas before that dose had been protective, in this particular experiment, it wasn't totally protective. However, when it had the 2B protein, it was. And actually, this difference is a little bit related to what I was mentioning before when we do challenge and the importance of standardizing the challenge that should be something really considered when we do these animal vaccine experiments, is that after doing the experiment and not being able to, although this experiment told us what we wanted, that the inclusion of 2B improved potency, it really raised an alert. Why before the 5 × 10⁹ dose was protective and now it wasn't? And it was because by mistake, this was a mistake in the lab, we have challenged the animals with a challenged dose 500 times higher than the dose that had been treated before. And when I say this, is we challenge our pigs with 10⁴ TCID50s established in different cell lines, and this time we put 5 million PFUs to challenge these animals. So this was really nice, though, that the 2B still protected, the construct with 2B protected. So the same thing happened in cattle, as I mentioned before. For us, it was a challenge. The only other serotype that by then we have made, in addition to the A24, it was the O1 campus. And we could never achieve full protection in cattle with the original construct. However, when we include the 2B in the preparation, we did improve the performance of the vaccine, although still one animal developed one lesion at the site of inoculation, and we consider that as in our scoring system. So if it's not in the tongue, in the case of the cow. So for us, a lesion in the lip, in our criteria, is considered that as a clinical score of 1. So interestingly, as I mentioned in some of the questions before, we found for the first time that inclusion of this the full-length 2B in our ad construct induced the memory, T-cell memory. And we noticed that that didn't happen, or was different than in the vaccine that didn't have 2B. So we also evaluated in this all this developmental stage of the vaccine, the effect of the number or the route of inoculation and the number of sites and the location of the inoculation. And we, in Plum Island, we always, and in Marvin's lab, we always try to work first with pigs because they are cheaper, it's easier, smaller rooms, etc. And I just, we noticed that by changing the route of inoculation from 1 dose intramuscular in the hind limb to 2 doses, 2 sites in the neck by the subcutaneous route, we could actually reduce the dose of the adenovirus 25 times. And in addition, we also evaluated, in order to reduce the dose and reduce the cost of the vaccine, the use of some adjuvants. And in those days, we started evaluating molecular adjuvants and TLR or RNA cytosolic receptors like poly-IC. And interestingly, we found that when we combine the adenovaccine with poly-ICLC, we could actually, this is a typo here, we could actually reduce the dose 80 times, not 100. So this was simply, I show the data because this slide is so clear that, when we inoculate 1 site intramuscular with a dose, in this case of 10⁹, the 3 animals that we use in this group, they all got sick. But if we just consider this site to 2 sites, the lesion score was lower. And when instead of being 2 sites, we use IM, we use subcutaneous, all of the animals were protected. So this is such a clear result on the effect of the route of inoculation. And of course, the doses were lower.
You have about 5 minutes, Teresa.
5
minutes.
Oh, well, okay, sorry, I thought it was half an hour. So again, I skip this. So we more lately tested the same adenovirus with other serotypes, like in the case of O1 Manisa, and this for the first time allow us to see the empty capsids during the manufacturing process. And interestingly, the O1 Manisa dose that is required for food protection, even in cows or in pigs, is lower than the 824. So in summary, for the first part of my talk, which is the early development, we have demonstrated that the FMD vaccine induces protection, and it works in swine and cattle, that 2B, in addition of the non-structural 2B of FMD, improved potency, that the best route of inoculation was subcutaneous, and molecular adjuvants could work as good adjuvants for this type of vaccine, and that was efficacious against different serotypes. So basically, this is when we are more or less in the middle of all of these experiments. We actually were already have an agreement, USDA have an agreement with Merial, but DHS came to Plum Island, and I have to say that they took over a collaborative effort in trying to move this platform to a different level and finally develop into a product that could be licensed and used internationally, actually. So we in our development, we have just in this graph that I stole from Luis, I guess. So we actually have reached more or less to 50% of the development stage for vaccine production for a new platform. So when we work with Merial, we realized that we were working with an adeno that was commercially available, a vector that is considered first generation, that was had some features, but couldn't be used for an industrial purpose because it didn't comply with all of the conditions required for this type of vectors. So Merial had actually this virus, this adenovirus, useful to use commercially, that was proprietary, and that it has a series of advantages over the one our originally AdBlue. So with the support of DHS and in collaboration with them and the companies, so more or less since they have taken over, they really have made an incredible effort in moving this platform to the stage this platform is now. First, DHS developed a method, an in vitro evaluation method to actually, that could be used for determine whether the vaccine had a profile and it would comply with regulations. And why did they do that? Because in our case, the adeno vaccine doesn't induce significant high levels of neutralizing antibodies. So the serum neutralization assays are not predictable of protection. So by using a combination of different biochemical and biological methods, they established a method that would allow for batch release, having a standardized test for a particular batch and serotypes. So they also took over and they did 8 studies, involved 150 steers, something that we could have never done, I guess, with the support that we got in USDA. And they demonstrated that, as previously demonstrated in our lab, that all cattle was protected, at least 90% of the cattle were protected from clinical disease with just one shot and challenge at 7-day post-vaccination, that the DIVA properties maintained in all of the vaccinated animals, and that commingled naive animals did not seroconvert for the adeno live virus that was given as a vaccine. In addition, more recently, they published this more recently, but these are studies that were done maybe 2 years ago. They show that the dose incorporation of this adjuvant that actually was tested in our lab with Marvin's group, where in the vaccine formulation allowed for 19 times dose pairing, and they did this experiment and allowed for based on a bovine protective dose of 3 × 10⁻10 PUs, and this experiment was done with 76 steers. A safety study involving 500 healthy beef and dairy cattle, which were vaccinated in the US mainland, and then randomly groups of 50 animals were brought to Plum Island, where we constructed even animal rooms to hold the 50 animals. The study was double blind. The animals were mixed, vaccinated and naive. They were all held in the same room. They were all challenged, and the vaccine proved to be consistently effective. So these animals include, not, as I mentioned before, not only beef, but also dairy cattle. 10 lactating cows were tested, and in the 10 of them, it was demonstrated that the adeno vaccine was completely absent from the milk. And as I mentioned before, there wasn't any shedding that made any naive animal seroconvert to adenovirus. So more recently, this more testing. In this case, they did 22 studies with 375 heads of cattle. So they did evaluate this vaccine against multiple serotypes, 16 different monovalent vaccines, and they show that the vaccine is effective against A, O, Asia, SAT2, and SAT3 serotypes in those studies. However, these vaccines was licensed in the US. It's only licensed for serotype A24, but we think that there is sufficient data to perhaps request a license for all of the other serotypes. But like, life is not perfect for anybody. So this vaccine still has several challenges. One of them is that and this is an experiment done with the AdBlue original from Marvin's lab. So the polyvalent vaccine didn't work as well as the monovalent, and we don't know why. So this is a field that we are currently exploring. We still have the limitations of all current vaccines, and even the new platforms that are being developed, that is a cross-protection inter and intra-serotype. The vaccine has been evaluated for the ability to prevent persistence, and it doesn't. So vaccinated animals can get persistently infected, like with the inactivated vaccine or the convalescent animals. And we still don't have enough data to prove which is the duration of immunity. We have preliminary data suggesting that 6 months are likely, but unfortunately, as you may know, Plum Island the animal facility was closed for the last 2 years. It just reopened a couple of months ago, and some experiments, unfortunately, that were evaluating this got ruined, and some that will be in the future, I don't know. We are all waiting and fighting among ourselves to run the experiments we couldn't in the last 2 years. And also the commercial vaccine that is with the commercial available vector, we know that it has some not as such as a consistency in the performance in swine. So with that, I just want to thank everybody that over the years in Marvin's lab have contributed to this project. Of course, he was the leader, and I consider him the inventor of this platform. This is the people in red are my lab now, and well, Faina Diaz and Segundo, she used to be in my lab, now she moved, is in Plum Island, but in a different department. And of course, the tremendous work that DHS and investment that DHS put together with Merial to develop and take this vaccine to the current stage of development. Thank you.